We now discuss the solution of a problem from the section Matrices and Determinants. This problem is related to the trace and determinants of a given matrix. This question has appeared in the Joint Entrance Examination Main held on 6th April 2023 in the first shift. The given question is, let capital A is equal to Aij 2 by 2. A is a 2 by 2 matrix where Aij not equal to 0 for all I, j, and A square is equal to identity. Let A, small a, be the sum of the diagonal elements of A and small b is equal to determinant of A, then 3a square plus 4b square is equal to. Right. We are given capital A, it represents a 2 by 2 matrix whose entries are Aij and Aij not equal to 0 for all I and j. A square is equal to the 2 by 2 identity matrix. Let small a represent the sum of the diagonal elements of A, that is the trace of A, and B is equal to determinant of A, then required to find the value of 3a square plus 4b square. We are given 4 options. We now discuss the solution of the problem in detail. Let capital A be a 2 by 2 matrix written as Aij 2 by 2. We write it as a 2 by 2 matrix whose first row is P, Q, second row is R, S, where the entries P, Q, R and S are all non-zero. Agreed. Given A is equal to sum of all diagonal elements of the matrix A, that is small a represents trace of A, that is P plus S, and B is the determinant of A, that is PS minus RQ. Given A square is equal to I, so let's multiply A PQRS multiplied by PQRS is equal to the identity matrix 1 0 0 1. Multiply. So if you multiply first row with first column, it is P square plus QR, and second row first column, that is PR plus RS, this one. Likewise, the other elements are computed and is equated to the identity matrix 1 0 0 1. Now equating these anti-diagonal elements, that is PQ plus SQ to 0 and PR plus SR to 0. So we write it down. So in PQ plus SQ, you can take Q common, Q multiplied by P plus S, and in this R is common, R multiplied by P plus S. So we write like that. So the anti-diagonal elements are written like that. Now take these anti-diagonal elements and equate it to the corresponding entries. Then Q times P plus S is 0 and R times P plus S is 0. But what are P, Q, R, S? They are non-zero elements. So Q is non-zero, R is non-zero. Therefore, the possibility is P plus S must be equal to 0. So P plus S must be equal to 0 since Q and R are non-zero. That means the trace is 0. The trace is 0. That means A is the trace. A is the sum of the diagonal entries P plus S. Therefore, this will give you A is equal to 0. Further, it is given A square is equal to identity. We have already used. Now, take the determinants on both sides. Determinant of A square is equal to determinant of I. Determinant of I is 1. Determinant of A square is determinant of A into A is determinant of A into determinant of A is equal to 1. That is, determinant of A is B into B square is equal to 1. So thus A is equal to 0, small a is equal to 0, B square is equal to 1. So we can now compute 3a square plus 4b square. Therefore, 3a square plus 4b square is equal to 3 times a square is 0 plus 4 times b square is 1. So that is 4. So 3a square plus 4b square is 4, and it is the answer 4 appears against option 4. So our answer to this question is option 4. So that is the detailed discussion of the solution of the problem from the section matrices and determinants, and this problem is a very simple and straightforward example. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.